Well, hi everyone, and greetings from Northern Michigan. This is Bob the Science Guy. Today we're on part 2 of my overview of slide rules and how to select a slide rule for your personal use. Today we're going to introduce some more sophisticated slide rules, what I call the engineering rules. And we're also going to introduce the slide rule that I would recommend that you get, and that is the Pickett N3. So let's cue up the music, learn a few more scales, and see how to actually use a slide rule in day-to-day life. All right, so here's a typical slide rule that we just used. This is my grandfather's slide rule, and underneath it is my father's slide rule. My grandfather was a civil engineer. My father was a mechanical engineer. We used to always joke that Dad designed weapons and Grandpa designed targets. Now, my father's slide rule is what's called a KE slide rule. That's the manufacturer that made it. And it's an American slide rule, and unfortunately I don't really care for them as much because they're kind of bland and unimaginative, but they do the job. Neil Armstrong used a KE slide rule. Now you'll see right here we have the D scale. We don't have a C scale on this because it's on the other side of the slide. And this has got a reversible slide as well, and it's got an A and a B scale. There's the K scale, the L scale. And then here are some of the inverted scales. You can invert the C scale, you can invert the D scale, you can even invert some of these other ones, the A and the B. Now, you'll also see something called an LL scale on it. Those are log-log scales. We'll go over those in a minute. Now, this is what's called a duplex slide rule, which means that if you flip it over, there's a whole other slide rule on the other side. Here are more of those log-log scales. There's your C and the D scale. Now up here you have something interesting. You have a CF and a DF scale. Now, a few minutes ago we did something where we multiplied 4 by 6, and we ran into a problem because if we bring the index out here to 4 and try and read the 6, it's way the heck out here. Well, what would happen if instead we cut this scale off right here at pi, 3.14. And then we took this half of the scale and we moved it over to here. Well, that's what we do with the CF and the DF scale. All right, so let's have a look at these folded scales real quick, and we'll take our problem from earlier, and that is to multiply 6 by 4. So if we come out here to 6 and multiply in the standard fashion, putting the index over the 6 and then measuring out to the 4, as you see, we're off the slide here. So one way that we could do that is that we could divide it by 1 over 4 using what's called the inverted scale, the CI scale. And the way that we would do that is we would find the 4 on the CI scale, put it directly over the 6 like any other division, and then read back to the index. Here's 2, here's 2.5, there's 24 or 24. Now the other way that we can do it is using these folded scales. So we'll go out here to the 6 and we'll go up to the CF scale and put the index of the CF scale directly over the 6. Then all we have to do is read back to the 4 on the CF scale and straight down. Here's our 2, here's our 2.5, there's 2.4 again. Now, why would you do this? Well, if it's more convenient for the calculation that you're using to use the CI or the CF scale, well, that's the scale that you want to use. Now, the other thing that's very handy is you can do something called tables on slide rules. So let's go to a table here. So down on the D scale, here's 2, and here is 2.2. Now, if we come up to the C scale and put the index directly over the C scale, we have a relationship now, 2.2 to 1. Now, as you know, there are 2.2 pounds in 1 kilogram. So 220 pounds would correspond to 100 kilograms. Likewise, 440 pounds, we can read right up, and that's 200 kilograms. But what about weights down in this area here? It might be a little bit more convenient to us to use the CF scale simply by putting the index of the CF scale directly over that 2.2. Now we can read pounds to kilos in a very large range. So for example, if you look at my weight is 195 pounds, and that will correspond to 80, 85, 86, 87, 88, 88.3 kilograms. And you can do that on this entire range. So again, use the right scale for the calculation that you're doing. Now the accuracy of slide rules depends on how long they are. Sometimes you can squeeze a little extra precision out of a 10-inch slide rule, something that is more like a 20 or a 30-inch slide rule, by using a little creativity when it comes to splitting up the scales a little bit. Now I'm going to start off by demonstrating this on a special scale that's on the Pickett, and then we're going to go into the log-log scales. So let's go ahead and have a quick look. Now let's look at a friend from our last episode, and that is the K scale right here. Now you recall the way that the K scale and the C and the D scale were related was cubes and cube roots. So the K scale is divided into 3 sections. It goes from 1 to 10, 10 to 100, and then 100 to 1,000. Then it starts off at 1,000 to 10,000 to 100,000 to 1,000,000. Now, notice that this is a 10-inch slide rule, and the distance from the one here to the one here is 1/3 of 10 inches, or 3 1/3 inches. Now, when we go down directly below the 10, we find the cube root of 10 is approximately 2.16. Let's see if we can maybe get a little bit more precision out of this. Now, what if instead we looked at the C scale on the Pickett here? The C goes from 1 to 10, and it's the full 10 inches of the ruler. Now, if we look right down here at the bottom, you'll see cube root signs. Now, the first row here goes from 1 to about 2.16. That corresponds to 1 to 2.16. So instead of being in 3 1/3 inches, it's the full 10 inches. Now the next section on the K scale goes from 10 to 100. Well, we can look at the C scale as going from 10 to 100 as well. And if we look down on the cube roots, we go from 2.16 up to about 4.65. On the second cube scale here, we go from 2.16 up to about 4.65. So that corresponds to this section of the cube roots. Likewise, if we look at the last section of the cube roots, again, what we're doing is we're going from 100 to 1,000, and we're reading down on the bottom scale of those cube roots. So let's take an example here. If we put 8 on the C scale, and we read down to the cube root, that'll be on the first scale because 8 is between 1 and 10. And our answer is 2. Now, what about 80? 80 is between 10 and 100, so we'll look at the second scale, and the cube root of 80 will be 4.29, it looks like. What about 800? Well, third scale, and we go 9.128, 9.28 roughly. Now what about 8,000? Now 8,000 is in the 1 to 10,000 range. So we look at the first scale, and we have a 2 there. Now recall that 8, the cube root was 2, so the cube root of 8,000 will be 20. 80,000 will be 42.9. 800,000 will be 92.6 or 7. See how that works out? So what we've done is we've taken the full length of the ruler and then we've split the K scale into 3 10-inch scales. We kind of just reversed it from where it was. Now you may ask yourself, why go through all this trouble of splitting up those scales? Now the reason that you do it is to give this 10-inch slide rule the accuracy of a 30-inch slide rule when it comes to looking at cube roots. This trick is used in a number of other slide rules, and it's also used on the log-log scale, which is what we're going to go into next. Now the log-log scales work in a similar fashion. We're going to read our answer on the C scale, and we're going to find our logs on the corresponding log scale. If you look at the log-log 2 scale, you'll see right here it's 0.50. Now, we're going to use this to figure out carbon-14 dating. Now, the way you do carbon-14 dating is that you take the half-life, which will be 0.50 on the log-log scale, and you put the half-life in years above it. And the half-life in years for carbon-14 is 5.73. Which means that if you have a piece of charcoal and it has 50% of the carbon-14 that you would expect to find, that means that the charcoal is 5,730 years old. Likewise, if you had a piece that you knew was 3,000 years old, you could put your cursor directly over the 3 here. Remember the table function of a slide rule. And you could read down and find out that you would have approximately 69% of the original carbon-14. Here's 65, here's 70. Notice that in red they move backwards. What if you had a sample that had 1.5% of the original carbon? Well, you'd have to go down here and you'd have to find 1.5%. Here's 1% right here. So what we'll do is we'll go up to 1.5%. and we'll directly read off 3, 4, 7. Now what is that? Remember, we switched the scales. We went from the LL2 scale down to the LL3 scale. So there's a change in factor of 10. So that's 34,700 years. This is kind of an important slide rule that I'd like to go over with you. It's got a couple of really nice features. This is an engineering level slide rule. It's a Pickett is the name of the brand. And this slide rule is an N3 and it's from 1962. The reason that I wanted to bring up the Pickett N3 slide rule is that you can use this online. There's a virtual version of this and I'll show that to you here in a couple of minutes. And the other thing is that this is about a $40 slide rule that has everything on it that a slide rule should be expected to do. There's only one scale on this slide rule that is missing, in my opinion, and that is a P scale, or a Pythagorean scale, and we'll go over that in the next section. But if you wanted to buy one slide rule to learn everything that you needed to know about the slide rules, get yourself a Pickett N3. Well, I hope that that was at least a nice introduction to the slide rule and some of the different types of slide rules. Like I said, this is what you want right here, is a Pickett N3. There are 2 links that are important in the description. The first one is a link to the International Slide Rule Museum, and they have discussions of every slide rule known to man there. They'll tell you what scales are on it, they'll tell you, tidbits of information about it, etc. But more importantly, they have what's called virtual slide rules there. So, let me see whether or not I can go ahead and bring that up. Now, that's looking pretty good. So, we're going to come down here and we're going to go to the virtual slide rule right here. Derek's virtual slide rule gallery. Now, for example, here's a pretty basic slide rule. As you see, simply by moving your cursor, you can drag that cursor around. You can move the slide, and then you can actually move the whole thing around. So here's one of the basic slide rules. Let's look at the scales that are on it. We've got our CD scale. We've got our AB scale. We have a K scale. We have our trig scales. And we have a logarithm scale. Now, you can also flip it over. And this is very similar to what we had on that first slide rule, which is pretty much a dedicated slide rule just to do these conversions. Here's the Picket N3, and that's the one that I use. Notice it doesn't have that, what they call eye saver yellow. This is a more traditional cream-colored slide rule, but it works the same way. And you can bring it back and forth. It doesn't have a fuller on it, but you can flip it over, and here are all your scales that you can use. You can play with this a little bit and decide if it's something that you would be interested in getting a hold of. Well, that pretty much handles everything that you would see on a normal slide rule. Now, there are some specialty slide rules out there, and there are some higher end slide rules that are very interesting, and we'll look at those in our next episode. For example, we have specialty slide rules like aviation slide rules. We even have this monstrosity, which is a Fuller calculator. We'll touch on both of these in our next episode. So until then, this is Bob the Science Guy signing out from Northern Michigan. Thank you very much for stopping by, and thank you very much to the Patreons and supporters of this channel who provided the funding that made all of this possible. So until next time, this is Bob the Science Guy. See you soon.